Hey, welcome to this video on powers, explanation of exponents. So let's start with this very simple example here, very important. What you see on the screen right here, I'm highlighting 3 to exponent 4. So 3 is considered the base, and 4 we call the exponent. So what that means, 3 to the power of 4. This simply implies that base 3 is repeated 4 times. So you find the result of that, and you'll see this is equal to 81. However, we will have even exponents, so we're going to call them 2n, and we will discuss later on odd exponent. N is the natural number. It is 1, 2, 3, and so on. I hope that makes sense. So, before we identify the major difference between -3 in brackets to the power of 4 and -3 without brackets to the power of 4, let us consider the following example. Take a look at this one shown below. 2 times 3 in brackets to the power of 4. And by the definition, this simply means that that base 2 times 3 is repeated 4 times. And yes, you can grab a calculator and figure it out that the answer is 1296. But this is not that important. I'm going to show you that this product, 2 times 3 repeated 4 times, can be slightly rearranged. So here we go. 2 times 3 to the power of 4, as shown on the previous page, is equal to that. Now let us regroup the product. So we can put together 2's as 2 times 2 times 2 repeated 4 times, and 3 times 3 times 3 repeated 4 times. And then you have 2 to the power of 4 is equal times 3 to the power of 4. Essentially 16 times 81, and the result has to be the same. There's no way that the result should be different. So what is the significance of that? That whenever you have a power expression and your base can be factored into factor A and B, in this example it was 2 and 3, this means when you solve this problem, or you can further evaluate, you can distribute that exponent n into each factor inside of the bracket. So remember, this is very important. Later on we'll show how that works in case when the base is a rational number. Okay, so let's go back to our example. -3 to the power of 4 is simply -3 repeated 4 times multiplied together. I hope that makes sense. Now we will have to become aware, if it's still not quite clear, that any negative number is expressed as a product. -1 times the positive value. So that works for any case that you can think of. So using this analogy, now -3 in each bracket is expressed as a product -1 times 3 repeated 4 times. Then when we regroup, we have -1's put together and 3 positive 3's put together and multiplied together. So -1 multiplied 4 times gives you +1, because you group 2 negatives at the time. So 2 negatives multiplied together always results with a positive number. So therefore this is just 1 times 3 to 4, and in the end this is 3 to the power of 4. So -3 in brackets, -3 in brackets to exponent 4 is equivalent to +3 to the same exponent. And that only works when the exponents are even. So a to 2n in brackets with negative sign is always equivalent to a to 2n. So this is always valid when exponents are even. So what about negative 1 without brackets to exponent 4? We have to understand the following. Negative 3 is a product of negative 1 times 3. Recall the BEDMAS. Exponent comes first, then after multiplication. So you would deal with the exponent, which is part of that expression, positive 3 to the power of 4 times negative 1. So be careful when you're dealing with this situation, when the base is not totally in brackets. So, in the end, you have negative 1 times positive 3 to the power of 4, so the result must be negative. So I repeat, the general formula here would be as follows. When you have a negative sign and a base a to even exponent, then this is just equivalent to negative 1 times positive base to that exponent. So I hope this makes sense, and this will be part of your knowledge from now on when you're working with powers with brackets or without brackets. So what about when we are working with odd exponents? So odd exponents are expressed in terms of 2n plus 1. So when n is any natural number times 2 generates even, plus 1 gives you always odd. So look at this simple example, but very important. Negative 3 to the power of 5, you repeat that negative 3 5 times. So 5 times negative number should give you a negative result, if you remember the rules how to multiply integers. So this is why negative 3 in brackets to odd exponent is equal to negative 3 without brackets to the same exponent, which can be summarized in this general statement. Any power in brackets when the exponent is odd, this is simply the same value as negative sign attached to that base with the same odd exponent. So, in other words, negative a to the power of 2n plus 1 can be seen as the following product. Negative 1 times positive a to exponent 2n plus 1. I hope this makes sense and you enjoyed this video, and see you next time.